high level understanding of what HDFS is, but not like really comparing it against like what is it a DD or like something else. And some of the other questions that are being done asked in the downstream.
Hello, hello. Please make the screen bigger.
Okay.
Okay, someone asked, is the screen share still running? Could you check maybe 要不要记录调一下吗？ Can everyone see his screen?
Yeah, I can see the screen.
Okay, because it's not loading on my other screen. Oh, one say that cannot.
Let me try and reshare the thing.
Yeah.
Is it better now?
Yeah, it is better for me now. Okay, okay. Yeah, let's get started. Let's get started.
Yeah, so nice. I forgot how are we going to do this? Do we read through the questions one by one or?
Right. So could you scroll up and look at the flow diagram I proposed? So if you don't actually know what to do, the proposed flow I gave the host was that we could leave some time for people to vote on which question they want to answer for, or have people collaborate immediately on the screen, or you could just talk it one by one. I think people do both. It kind of depends on what approach you want to visit it.
Okay, I think for now we can spend like 5 minutes to read through some of the questions and see like which ones stand out more, because we have like chapter 4 and 5, so I don't want to spend like too much time on like just chapter 4 itself.
Yeah.
Is that okay with everybody?
Yeah, that's good. That's good. Could you open a timer for like 5 minutes, and then I've opened a vote column, and let's do a small collaboration on the question list.
Okay. Sure. I set a timer for 5 minutes, but you guys can't see it. So it should end around 7:12. Yeah.
Okay. Also, could you change the screen to like a lighter background, so that it's easier to read for others for a sharing session?
People got safekeeping. I don't think so, Major. It's a strong call. I am the highest one. Animals less living specimen species Oatmeal versus Astro.
I held on.
It's just don't make my son.
Can Ethan see the screen?
It was me that cannot see it now.
Expression makes me unstoppable.
Asian, is the time up yet? I
Oh
cannot
yeah,
hear you.
just okay.
Lies.
Yeah, the 5 minutes is up
Right.
because I
So,
can't speak Chinese.
yeah, I mean, it's fine, it's fine. So I think we already had quite a few votes. So let's start the session by explaining the question that had the most votes. And then we probably could also pick the ones that we want to answer the most as well.
Just tell me you know.
Okay. So it seems like it will be the first question. So what's the difference between the Avro and Parquet data format? So for Avro data format, it is formatted via rows, right? So if
Could we make it
realize
even
it might be
bigger?
a bit- Mm, okay, wait.
You see them into its planet, we're interested.
So that's better.
Is this, can you guys see the diagram?
It is better for me now. I'm not sure for others.
Okay, anyways, like
Mhm.
so
Can you
there's
zoom in a little bit?
okay.
Zoom in, yeah. Okay.
So for Avro and Parquet, there are different data formats. One is so for Avro is a row-based data format, as we can see here. It's very similar to how our traditional like SQL data is being stored. It's all like in a singular row, whereas like Parquet data is formatted via columns, like what you see on this image right here, where your identifiers are in a column, and then you just have your data inserted column by column instead of row by row. So what this does is this affects how data is being queried. So if you look at these two like Excel images here, so if the data is being stored as a, so if let's say I have a query that says like, hey, I want to get the sum of all age. If your data is in Avro format, which is row based, it will be stored in this manner, right? Where every record is connected to each other. Like so for the age, as you can see, it's in purple color. So if it's a row based, say if it's stored as a row based data, if you want to query the age, for the data you have to like query through like multiple hoops, like one block here, one block here, and one block at the other end. Whereas if you do it based on a column data format, you can just say that I want the whole block of age will just be one single block, which is a lot more efficient for data reading. Yeah, so that's essentially the high level difference of what the difference between Avro and Parquet data format. Is it always more efficient? For Parquet, it will be more efficient for reading, but not for writing. There is a hybrid model, but I didn't. There's a hybrid model between like them, but I didn't went and go through it. But I did find that there's some people that they mix the formatting I can't remember how did they explain it.
So we must be headed towards the vessel.
Okay.
Northeast, 113 degrees.
17. Listen straight.
You said you wanted the shortest way.
What's the difference between roles and ranges?
Because I think we also had some discussion during the early chapters, which people do talk about the difference between the efficiency between column-based storage versus row-based storage. And I don't think that the statement could be just as simple as column is more efficient for reading but not writing. Because for writing there could be a lot of different use cases you need to support. For most business use cases, maybe writing is more efficient. Maybe writing is usually performed on the row level, so that the row-based storage is more performant than that. But for reading purposes, not all type of reading were
Directing products, projected plan, 140 degrees east, also.
anyway, I'm just trying to add on this statement by itself.
I definitely agree, but then again, from the paper, it states that it does like a two-step conversion. So one is they read the logs from Kafka as a array format, so like row-based, and then they merge the information into a Kafka format, which is column-based. So this just leads me to assume that the necessary like action is because the conversion was necessary because like they look at like more multi-dimensional data, which is much more efficient for a column-based data format. Yes. Yeah, because as you can see here, like in this diagram that I found online, once they like start after they process the data after they load the logs from Kafka, and then they store it into the raw like a raw table, they do the merge and compaction to Parquet, and these data are being served through like Hive, Presto, or Spark, where they can just query it.
There was too sophisticated to
Okay. So let's see what's the next question. So what's the difference between Presto and Hive? So on a high level, like both Presto and Hive, they have like similar capabilities to query and process data, but the way it is implemented is quite different. I think for Hive, it's more of it is part of say like a Hadoop ecosystem. So that whereas for Presto it's more language agnostic system where they have a concept called connectors. So you can actually through Presto you can connect to multiple different data sources like Postgres or Spark or even Hive itself. And when it comes the paper, like the main thing, the main difference between like Presto and Hive would just be that since Presto introduces like fast and interactive query, is it a data resolver or something? Let me see what the image and this is here.
I'm sorry, I can't hear you. 听不到。
Oh. Okay, wait, can you hear me now?
Yeah，现在听得到了，现在可以，现在可以。
Is it very soft?
I think there was a moment that you become very soft, after you've been explaining the connector stuff. So we are not really sure where
Okay.
you are scrolling or you are thinking about stuff.
Okay, wait. I hope this is better.
Yeah, it's better. It's better.
So for the connectors, so what do I mean by connectors? So as PrestoDB as like a query engine, it is able to connect to multiple data sources because like they have a connector layer. So this connector layer, as you can see from the image here, it can connect to like MySQL, Mongo, Postgres, Hadoop, HDFS, Redis, and Cassandra, and many other more. So it's basically like a universal SQL query engine that can run on many different type of data sources. Whereas for Hive, it's just locked into a Hadoop ecosystem. And as for like query latency wise, Presto is a lot more faster than Hive because Hive performs like batch data processing. Yeah.
Yeah. I think we can move on. We don't have that much time. You can just move on, explain each question. So I'll type my questions out.
Okay. Okay. So what is HDFS? Is it a DB or something else? Sadly, I only know a high level answer to this. It's just that it's just a distributed file system. I don't really, but from the name of it, it seems like it's quite it's a file. The main difference I can see is just that it's a file system compared to a database. If any of y'all know like what's the more in-depth difference, feel free to just hijack this session. Nope. Okay, let's move on. Why is HDFS ever needed? Can't we just use some file system on the ground?
It's time. Use for joy this year. Perfect doable view. Non-stick coating for easy cleaning.
I will skip this one also because I don't know how to answer this.
So waiting. Use for joy at the following time on Terra 5 and relaunch.
What role does Presto What role does Presto exactly serve? Is it a pre optimizer that leaves the developer? So for this question, I believe what the role that Presto does is, or rather like the advantage of just using Presto is its ability, or rather it provides the lowered query latency when processing a large amount of data when dealing with the scale like Uber, where they have to ingest and process a lot of data. and when they want to try to come up with a lot of interactive queries, made available for others, using Presto allows them to, because if you were to use Hive, from what I've seen, to build up like an analytical dashboard, it might take, or rather to run a query, it might take like few hours. But for Presto, it's like in a matter of seconds. So I think really the speed here is the speed of Presto is what sells it for big data companies like Uber, which is why they use it over Hive. Yeah. Is Presto IO memory or CPU heavy tool? I would say that from what I read, it seems to be a memory heavy tool because the way they achieve the speed is load the data in memory instead of writing it into like an actual data store for it. Difference between HDFS and data warehouse. Can't answer that. Explain what's projection aggregation limit represents. Okay, I can't answer that either. Okay, I think so for the questions that I've skipped that you guys have expressed interest but I can't answer, I will probably look at them this week and come back to it for the upcoming session. But yeah, I think that's all from my end. It's just nice 7:30. I guess I can hand it over to the other speaker.
To chapter,
Sorry?
you mean we can move to chapter 5?
Yeah, we can move on to chapter 5.
Okay. Then let's move the host to ensure.
Nothing to worry. Now,
Okay, well,
Philip says the location where the major disappears. My life.
那个 Hi 那个 Hey 有
嗨，您看到我的画面吗？
可以，
就是有这个 sharing 啊，有这个 Notion 吗
有。
？OK 就是方便我就用英语做介绍。
我看你
Okay.
哪个方便啊？看你哪个方便。
Okay. So I think this chapter is actually not very technical. It's mostly about how Uber based on their use cases and build a system. So now after introducing so many technology that they use, they now showcase some use case that in Uber. And for me, yes, soon. Oh, okay. Is that okay? Cool. So so I will be talking about the search pricing and the Uber Eats restaurant manager. So for the first one, so what is actually the search pricing? I don't know if any one of us has used Uber, but in short, it's like when a particular area there are a bunch of people trying to request a Uber try to request a driver, and the platform will sense that, oh, there are so many demands, but we don't have enough driver. So in order to make sure some clients got their urgent request, so they perform a machine learning algorithms. So it's kind of like real-time processing, like based on the amount of people in in the area, they calculate the price. So they have two types of two ways to showcase the price. The first one, the one on the left side is the old one. So I guess it's just increase the price by the multiplier, and the right one I think is the new one. So they now instead of using the multiplier, they have applied to additional fee to the right. And if you want to know more like why they're doing in that, how to balance the benefit from driver and the client, you may want to read the paper about the pricing, but I'm not going to deep dive into that. And yeah, should I go through one question by question, or is there any question you want to ask? Cool.
I don't have any ideas. I think this chapter has been not so hard for me, so I think we can just
Yeah,
go by
yeah.
question by
Okay,
question.
okay, cool.
We finish it.
When I reading the paper, yes. Mhm. Okay. So when I was reading the paper, I don't understand some terms, like for example, why it's called sync, especially called sync key value store. So I found out it is called sync because it's the final destination where the process data is sent to for storage. Because in the Uber real-time data infrastructure, there are multiple storage like Pinot uh, or other like HDFS file storage. So so I think the sync here means the final destination where it doesn't move anymore. And okay, so when I read the paper, I come up with a question like why search pricing favor data freshness and availability over data consistency. But in order to know what this question is asking, we have to understand like what is data freshness, availability, or consistency. I think these have been mentioned in the early chapter, so I just copy and paste and put a uh, put a meaning here. Yep. So I think the reason why they favor freshness and availability over consistency is because it's a very real-time decision making. Because the demand is keep increasing, decreasing all the time. If they want the driver or the platform to calculate the up to date pricing, they will have to have a very low latency data, and they will have to collect the data. I mean, the data should be consistently like accessible to the platform. Otherwise, they can't calculate, right? So I think this is the kind of business decision making. Like you need to trade off from consistency, because if a certain area there are a lot of clients, maybe we lost data from one or two clients is acceptable. So I think that is why they prioritize freshness and availability over the consistency. And I think this few question just try to explain the answer just from previous chapter. I think we talked about it already, like the how to increase the data freshness just using the consumer proxy. And I think active setup will be introduced in chapter 6. And yeah, if you're interested, this is some pictures from the official website showing like what you will see in their applications, like for example different categories like satisfaction of different dishes, sales, and the service quality. Yeah, I think that's my sharing. I mean, yeah. what's the cause of consistency over freshness? Um, Cost. So the cost here, it means I think it means like there's the consistency in here. It means the data integrity and the duplications across the regions. It means like the data that receive is correct or is with no data loss. But at this stage, because there are lots of clients, so I think maybe a few data loss they don't really care, or the duplication. I mean, it doesn't change the results from the algorithm a lot, so they favor freshness and availability over the consistency. Yep. Freshness. Freshness is like it's talking about when the data is available for processing or queries. So there are some examples called seconds level freshness. It's talking about the data are available seconds after it has been produced. For example, like when I get into a certain area, a very busy area, and my Uber app will instantly notice that I enter a very busy area, and it will send to the platform and telling it that, oh, one client maybe is requesting for a car. So it's kind of this kind of thing. I don't know. Does it make sense? And yeah, any more questions?
我觉得我可以稍微讲一下那个 restaurant 那边的那个例子，就是像我有贴个图嘛，是因为我之前看那个 DDIA，就是那个 Design Data Intensive Applications 那本书，它前面有讲到，就是 Twitter，我记得在 Twitter 就是网络上有个很著名的案件叫推特他们自己的架构的也，然后 Twitter 它原本就是怎么说？你可以想象 Twitter 一开始他们只有用一个 RDBMS 在做所有的tweet 的 insertion 跟所有的 tweet 的 search， 但是后来发现一个问题，就是他们的那个 tweet insertion 的话，其实最高频率他们那个 server 大概只需要1秒，就是怎么样 ？They only need to support up to a few thousand inserts every second, but the reading part was way heavier compared to the write。他们大概需要1秒，大概需要读取300万次左右了，就是以推特的规模来说。那所以就是这种时候就是怎么说？前面讲到，我在 reference example 里面其实也蛮像，就是他们讲到 Twitter，他们因为一般的 RDBMS，他们实在是太难去 scale 成可以支援这么高强度的写入的读取的，所以他们只好就是把他们的模型转换在一个比较像是 mailbox 的一个模型，就是 you have a RDBMS that's particular deal with just inserting those tweet records, but then 就是在推上面有一堆账号，也要每天都要这边一直 refresh 那个 timeline 嘛。那他们会把每个 timeline 都设计成一个 you can imagine it as a folder in a file system, and then they would like spend 5 seconds to try to move those inserted tweets as events into every user's timeline folder. And then since they have this segregation between write and read, they could have 他们就会可以取得就是更高的 throughput， 这样就是读取量效能会更好。那我觉得这跟 restaurant 这张蛮像，就是这个案就是你去把那个 consistency， 把 consistency 给那个怎么讲，给取舍掉，就是因为你让你的 那个 mailbox 跟你的那个 tweets 可能会有段时间就是没有 sync，可是你这样在读取上面会更加的快，原因是因为你那个 folder 永远都是存在的，然后你也可以无限的扩张的。
And I think I can also think something about why they trade off consistency, like maybe in Twitter or Uber. For example, like when a client, if they can't read the message like properly, maybe there's some error. They usually just refresh their applications. I mean, it doesn't affect a lot to the customer himself or herself. So I think yeah, like when you're calling with someone and there are a few seconds you can't hear what they say, you would just ask them to repeat that sentence, right? So I think that's kind of one of the reason why they take off take off consistency. Yeah. 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 Any more question? Yeah. If no, I think it's Alan's turn.
那个 Alan 有要帮忙回答准备一些内容吗？Hi Alan。Hi Alan。
Hello，
Hello。可以。
我讲一下下面的图，我可以用中文讲，
可以啊，都可以。好，你可以分享一下荧幕好了，这样我们比较可以跟着看你的目前的那个就是展示的东西是什么，好吧？我们听不到你，你是用 mute 吗？
等一下，我在研究怎么把它弄上来。
好，
没用
加
Make
油
直播过。
哦，好。
这样有吗？
看一下
这样有直播吗？
有，我看到，我就可以再放大一点点，让那个图片只在就是跟荧幕的大小差不多这样。就是大概什么网页缩放之类的，
网页缩放，
什么 Command 加之类 ，Command Plus。对，这样那个图片稍微大一点，这样我们只要看到那个文字。
好，那我现在开始讲说，那个他后面介绍的 use case 就是那个500亿他们需要有很多的机器学习的模型在那边运转，所以他们自己会用到很多外部的一些资源，像是 TensorFlow 啊、Spark 或者什么可森爪之类的，他们都利用开源的资源。然后因为不同的 domain 需要的模型跟工具都不一样，所以他们有很多个机器学习的模型需要去做deploy 跟训练。然后因为大家如果有在做训练的话，都会知道，如果每个人训练的东西都就是资料来源都不一样的话，那个整合起来在应用上就会比较麻烦，所以他们就想要开发一个自己的机器学习的相关的平台，可以建立自己的 AutoML 的流程。所以他们主要会有分2个阶段，一个是他们总共会有分线上层跟线下层。然后这个是他们管理资料的状况。他们的 Kafka 主要是收集到他们线上用户的一些资料之后，他们会直接把它导入 Hive 的 他们的 Hive Store，然后他们自己的后面会有一个 Data Lake。Data Lake 他们在从 Data Lake 里面去取资料的时候，会先做一些 Feature Engineering，去把这些资料丢到 Hive 的 Store。然后这个同时的话，他们因为做这些动作是为了训练，所以他们会把这些资料放在一个 Training Set 中。然后，因为在 streaming 的状况下，我们是没办法直接去采用，他们是没办法直接去采用 Hive 的那些资料结构的，所以他们会将 streaming 的资料丢到他们的 Feature Store 里面之后，再把它丢到 Cassandra 的 Feature Store 里面，让我们的线上的一些他们线上的东西可以去做 consume。然后接下来他们就会做训练模型的一些动作。然后在训练模型的时候，他们在中间这一块 batch 的 training 这一部分，他们自己有设计了一个语言，是可以让大家的 feature 去产生的方式做一个规范化。他们可以用很function的方式去取得 feature 跟做一些取得 feature 跟使用 feature。对，所以这些是他们的取得 feature 并 training 的地方。然后他们 training 完之后，会再把它放到一个 Cassandra 的 report 里面，然后他们在后面就可以根据自己的需求，如果是他们有想要去训练新的模型的话，他们可以从这个 report 里面去拿取相关的参数以及资料。对，然后再来是他们的 deploy， 他们 deploy 就是一样是分2层，一个是会直接把它丢到 real time 的 service 这边，然后一个是线下层，因为他们训练的时候是想一下，他们因为机器学习的训练的话，它的资料会越多会越准确，所以他们同时除了在线上的一些模型的 predict 之外，他们在线下也会持续的用他们的历史资料对那个模型做一个 fine tune 的一些动作。然后他们做完 fine tune 之后，他们的线上层会直接通过就是走上面这一条 Kafka， 然后 Strange， 然后 Cassandra， 然后再直接到他们的 training 过后的模型这边，然后客户端会把资料传过来，然后再得到他们的 prediction， 然后这里也是会有一个历史资料的 training 的 prediction， 然后会存在一个 type 或是 Kafka 的资料，然后这个是他们就是训练完模型去预测的部分，然后预测完之后，他们要去做一些监测的部分的话，他们会再把这些资料再丢到这一层，应该就是 Hive 的那些历史的那些资料里面，把它存起来之后，再去做一个，再把它导出到他们去针对这个模型做那个 performance 的监控的一个地方，然后可以得出他们经过拿到这些资料去做的预测是否好坏，然后去跟进他们的模型，这样。我分享大概到这边，有什么问题的吗？可以解释一下为何要 data。然后我自己的认知的话 ，data lake 比较像是一个你会把你的任何类型的资料都丢到里面，像是AWS 现在就很推 S3是他们放个 data lake 的东西嘛。然后因为他们是一个 Object Store 的类型，所以它任何的资料都可以丢进去。这样子的好处是我们在使用资料的话，我们可以确保全部的人的资料源都是一致的，而且经过那个 data prepare job 这一过程之后，可以让我们更确定我们在 Hive 那边里面取得的资料都是正确的。data lake 应该就是为了保持一个资料源一致的东西了。然后 Cassandra model 对，它就是储存有拿来存训练好的各种模型，然后里面会有参数跟训练的历史资料的 metadata。因为在 这一层里面它有一个 Hive 的 feature store，它把它丢进去之后，它会记录说它用了哪些 feature，然后用了哪些资料，哪些人训练了这个 model，所以他们就可以很好的去管理这些机器学习的模型。大概是这样。
我有
还有什么？
个问题，就是
嗯
data lake 跟 data warehouse 它们的区别是什么？
我觉得 data warehouse 比较偏向于是你已经处理好了资料，这个，因为这一点刚好我的工作上常常遇到说，因为在他们在 AWS 的定义啦，他们的 data lake 的定义是，你可以把全部的资料都丢到上面去，你可以不用做处理就全部丢到上面去。然后就是那以 AWS 的架构来讲，他们那个东西就是 S3，但是以 data warehouse 的角度来讲，那个就是 AWS 上面的 Redshift 的资料，因为你需要把 S3的资料经过一些 ETL 之后，再把它存到 Redshift 上面，然后大家要去做一些模型的训练或是 query 资料，全部都从 Redshift 去拿的话，就是那边就是一个 data warehouse 的概念。我觉得差别就是一个可能要经过整理过，一个就是你想要丢什么就丢进去，然后你在 data warehouse 那边可能确认某些东西，你就可以回去 data lake 去搜寻，这样。我的理解是这样。
好，OK，我这样有比较了解。那我还有一个问题，就是所谓的 ML 模型是指怎样形式的资料啊？它是 binary data 吗？还是
就是模型
CSV？
它训练出来有看是用什么东西的训练，就是有些出来会是一个 Pico 档，然后你就只是把那个你要去 reference 的时候，通常是把那个模型 reference 下来，那个模型已经带着你全部的资料的历史的那些，简单来说，模型就是 parameter 的组合，然后你可能去 reference 之后，你自己还要再经过一些，因为我们前面有讲过说，你在 feature engineering 的时候，你已经对资料做一些处理过后了，你可能就是进入模型，然后 reference 出来之后，你的资料再经过一轮的 ETL 再丢回去这样。所以模型的话，它里面就会有一些参数啊，然后跟它训练好的一包的 Pico 档或是什么档就会在那边，然后根据你使用的套件不同，可以把它揉下来，然后直接去做 reference。
好，OK，我了解，谢谢。
还有人有问题吗？
诶，如果关于 data lake 在里面的话，这章我讲到他们Uber 的 data lake，他们是用哪一套在做的吗？
这个他倒是没有讲，
他没有说。
他就是直接对他没有说。
OK，
可能我回去可以再找看看他们是怎么做。
好，看一下 sync store。OK，那个就是我刚刚听到你讲到说 data warehouse 是比较被处理过的资料。我
对，
这边
比较偏向那种被我自
我
己
因为我对这个领域没有到很熟，所以我想问，就是这个处理过的定义是什么？因为光是讲处理过，我可能会想，就是他可能会做一些 application，或者说把它变得比较好查询，或换一个资料格式，还是都会做吗？不好意思，让你回答。
不一定，有时候甚至是说你要对某一个 column 做一些特别的处理，像是我这个 column 可能结合其他两三个 column 去做一些数值化的分析，或是你自创可能要经过什么正规化什么的，这些都是 ETL 因为针对机器学习的模型的话，有时候你会想要把它给dummy，就是你那些类别资料你要去做一个类别化的分析，数值资料你可能它有一些遗失值啊，或是一些那个极端值或者什么的，在这些都要经过我们的逻辑去做处理之后，把它存到 data warehouse 里面，然后再去做一些处理。因为你这样子机器学习在训练的时候，你可以直接从 data warehouse 里面去拿资料，然后根据你的需求再做处理一次。因为资料处理是很耗时的，就是要定义，然后要检查，那些都比较麻烦，所以才会有 data warehouse 这个概念。 不用每次都去 data lake 捞出来，然后再想一次定义，然后再重新整理一次，这样。
OK，好，我想一下，对，因为读上一章讲到 Flink 跟 Pinot 那一章好了，我感觉在比较他们 streaming 或那种比较偏 feature 的开发，他们对于那个 data pipeline 的做法真的是逐渐转成不同情境要查询或是 application 上使用比较方便的格式，所以这样听起来 data warehousing 其实比较不太一样，它比较可能是为了不管是你们为了 ML 的一些需求。然后像是德智都有讲，就是把它变得比较标准化，或者说把极端值或一些该预先算好的一些统计上的东西先算出来，这样是这个意思吗？
就是因为有些资料的话，有时候你没办法控制那些资料会长什么样子，所以用户有些资料过来会非常的杂乱之类的，所以要经过处理过。好，还有什么问题吗？
没有问题了。
没有的话，那是不是就
好啊，
可以
那个
结束了？
对，那个好，我们今天感谢那个 Alan 跟 Shin 的分享，没有分享就是带的 Office Hour，那个其实这2章我自己读起来是，我大概就做结尾啊。这2章读起来我是觉得比较 chill 了。那个第4章我自己比较多问题，但是因为我看大家可能都比较放轻松在读，所以不能读到那么深。那个 Shen， 那个我们就让你下周就是因为还有1周是要做那个 sharing 嘛，你知道这件事吗
Yeah.
？Yeah，就是那我们下一周反正第5章我觉得应该就是可能再带一下有没有什么要讲啊，但是我们可能就做你的让 Shen 你去多准备一些 Presto 跟 HDFS 的一些比较实作上的一些细节，这样让来做 sharing，这样 OK。
And can I just read a bit more in depth about what they do, right?
Yeah. There really more question on how exactly this tool works. I don't on the original paper, they didn't really reference those that much. They just say that they used HTFS for some purposes. But we normally organize our session into sharing and office hours for every 2 weeks. So next week, I think you would probably cover the most content on next week's sharing, especially when chapter 4 was probably the one that could have the most depth on. Is that fine?
Okay. Yeah, it's fine. It's fine.
好，那我们下周我们就那个请迅跟Hey 还有 Alan 做最后的那个就是分享。那我们今天 Q&A 时间就差不多了，因为我们算是这周比较多人那个需要用英文来沟通了。那个大家如果不习惯的话，我们未来会再整理一些意见，看把它排得更好。但因为我们这个当初版就蛮多各式各样的人都有参加，所以大家就习惯或是我们适当调整吧。谢谢。
哎，稍等一下，那下一次是9点吗？还是一样是7点？
我下个礼拜应该就可以恢复正常，就是今天要搬家，所以就要提早，不好意思。
OK，我觉得如果要改，就是有时间异动的话，要先提早说，因为我也是今天突然想到，原来是7点。
哦，你说我再预告一下，就是多预告几次之类的。
可能要就是直接写在上面。
我其实有写吧。
有吗？
就是我上礼拜结束的时候，我有发一个 announcement， 然后我礼拜的时间我有改。
好吧，可能是我的问题。
就是 people 大家一定会 lost 掉了。我觉得很，我已经提醒一次了。
好，没关系。
好，那这样啊，那有什么回馈关于这张，还是其他想要做 no sharing 的，都可以后续在那个 channel 上面跟我们说。 然后这也是我们第一次使用这个 stage 啊，所以大家有什么回馈来跟我们说吧。就这样，下周日见，拜拜。啊，Goodbye。
拜拜。